Hola flacos, Clovis here, again. Welcome back. First of all, I would like to call your attention to the recent videotape on this channel about what's a function. Second of all, I highly doubt any of y'all watched that video. It's just as well. In that particular video, as I was explaining what a function is, I used a visual aid of a graph of a function, but I neglected to explain how to graph a function. As I said at the time, that video was no graphing video, and I stand by that. Nevertheless, I will attempt to rectify the situation, starting with this videotape. In other words, you gonna learn exactly how to graph a function. Maybe in this video, maybe in the next one. But before we do any of that, let's review what a function is. Like this one. What makes this a function? When you put something in it, like an x, it does some math to it, like times it by 4. That's number one. Number two, and most importantly, whatever go into this math statement, only one result come out the other side of it. Put a 6 in it, times it by 4. 24 is the answer. That's it. One input, one output. That's a function. All right. If you ain't understand that, you're probably gonna have to watch the What's a Function video lesson I mentioned earlier. I would say click on the link up here in the description, but I ain't put no link down there. Just do an internet computer search for what's a function and watch the video. It ain't gonna be my video that come up in your search, but I hope you find it helpful all the same. Okay, back to the matter at hand. How do you graph a function? That's why we're here. If you want to understand how to graph a function, first, you got to understand what's a graph. Here go a graph right here. Actually though, since we in the math of algebra, we're going to refer to it as a coordinate plane. It's called a plane because it's flat. And it's a coordinate plane because every point on the plane, or graph, can be represented by a pair of coordinates, also known as numbers. One number from this across line down here, and one number from this up and down line right here. It's like that game Battleship you played when you were a kid. Except in the game of Battleship, instead of two numbers, it's a letter and a number. D4, punk! Oh, that's a miss? Alright, I'll try again on my next turn. Anyway, on this type of graph, you only gonna use numbers. Take this dot right here. Look like it's just a regular dot, but it ain't. We on the coordinate plane, son. We got to represent that dot with a coordinate pair. Again, a coordinate pair means two numbers. So how do I find them two numbers? Check it out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. In other words, the point on the graph is known as 7, 5. Why? Because it's 7 spaces over, 5 spaces up. 7, 5. That's the coordinate pair for this point on the graph. And not only that, any single point you could possibly wish to identify on the coordinate plane can be represented by a coordinate pair. Just like that one. By the way, you may have noticed that this graph ain't got them lines crisscrossing across it to make it look more like a graph. It's because I ain't feel like drawing all them lines. Let's do another example. How about this dot? What's the coordinate pair? All you gotta do is count. 1, 2, 3, 4, 5, 6, 7. The coordinate pair for this dot is 1, 7. 1 over, 7 up. No big deal. It's just one small wrinkle. The coordinate plane, it's got 4 parts in it. Part number 1, 2, 3, 4. Each of them parts is called a quadrant. And the wrinkle is this. Positive numbers ain't the only type of number in the world. It's also negative numbers. But don't worry about it. It's pretty straightforward. Just watch. Positive numbers to the right, negative numbers to the left. Positive numbers to the up, negative numbers to the down. Entonces, negative 1, 2, 3, 4, 5, 6, 7, 8. Positive 1, 2. What's the coordinate pair for that dot? You may already know. Negative 8, positive 2. Now sometimes both of the numbers is negative. Watch. Negative 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3. The coordinate pair is negative 8, negative 3. I have now demonstrated the proper use of the coordinate plane. Just one more thing. You may have noticed that all the points we was working with on this graph just so happened to line up with the numbers on the number line. Very convenient. But the world ain't always convenient. It's an infinite number of numbers in the world of math. And by the same token, it's an infinite number of potential dots on the coordinate plane. And some of them ain't on regular numbers. Like what about this dot? It don't line up with no regular numbers. It's between 5 and 6 right here, and between 3 and 4 right there. So what's the coordinate pair? It's all right. Sometimes on the coordinate plane, you got to guesstimate. So I'm gonna call this 5.23.8900. Is that the real coordinates? I don't know. But it's gonna have to be good enough for now. All right. Assuming you were paying attention during all of that, you now know the first step for how to graph a function. You know what's the coordinate plane. It's this right here. It's a graph where every point on it can be represented by a pair of numbers. And them numbers, written in a parenthesis, separated by a comma, is a coordinate pair. Okay, that's it. Go back to class. Good luck with your schoolwork. Bye.